In this video, we want to talk about how to find the trig function value for any given angle. And so to do this, you're really going to only come down to just two important tools, your unit circle, and then a little way to remember where our trig functions are positive or negative, depending on the quadrant they lie. So you should have seen the unit circle in a previous video. If not, please take a look. Here is quadrant one of the unit circle, and that's kind of remind us of what we're looking at and where this comes about. So the unit circle comes from our special right triangles. Remember, in a 30, 60, 90 triangle, the side opposite the 30-degree angle is length A, or whatever you want to call it. But the side opposite the 60-degree angle is always going to be that number times root 3. Okay, and the hypotenuse of that triangle is always going to be twice that number, twice the smallest side. Okay. Now, in a unit circle, we call it a unit circle because we let the hypotenuse. Well, yeah, it is the hypotenuse, but the radius of that circle equal 1. I said hypotenuse because I'm thinking of this right triangle here. So we're letting the 2a take on a value of 1 in a unit circle. If you set those equal to each other and solve for a, you get that a is 1/2. So that means this little side here would have to be 1/2. This side opposite the 60-degree angle would have to be 1/2 times root 3, or root 3 over 2. And hence that coordinate there, to get to that point, I have to go right root 3, up 1/2. So for a 30-degree angle on a unit circle, that's the coordinate of that point. All right, that's how we're getting that value. And why that helps us is on a unit, well, if you remember the definition of cosine, whether you're using the point definition, x over r, or SOHCAHTOA, cosine is the adjacent over the hypotenuse, right? The side adjacent to your angle over the hypotenuse. So it's root 3 over 2 over 1, which is just root 3 over 2. And so this gives us the cosine value for 30 degrees in that x value. Similarly, for the sine value, you get 1/2. So every point on this unit circle all the way around is giving us the cosine value of that particular angle you're looking at and the sine value. So it's a very convenient way to remember some common trig values, or sorry, some trig values for common angles that we work with. You could definitely always get them by building the special right triangle and kind of going about it this way. But that could be time consuming if that's your only method. I would recommend the unit circle. So let's see how we could put this to use. So one benefit of knowing quadrant one of the unit circle is that if you ever just encounter a question, what's sine of 60 degrees? Well, we could just consult our unit circle, identify the 60-degree angle. We know the y value is the sine value. So sine at 60 is a root 3 over 2. So what about other quadrants outside of quadrant one? What if we were asked to find sine of 120 degrees? Well, first thing is to really just think about where that is. That helps to establish where that angle is, and really we're after its reference angle. So if you recall, going around the circle, we start at 0. If you go halfway around, we're at 180. All the way back around again, we're at 360. So 120 degrees falls into quadrant 2, right? You would have to go all the way to 180 and then give back 60 degrees. And that 60 degrees we just mentioned is really important because that is the reference angle for 120 degrees. Remember, the reference angle is the angle that is it's the angle distance away from the x-axis. So whether you're on the left side of the y-axis or the right side, or whether you go up or down, the reference angle is basically how far away are you from the x-axis. And that's important because it tells us how our pizza was cut here. It tells us what type of slices we're using. And so therefore it's letting us know this cosine and sine values. So as soon as we identify the reference angle as being 60, I want to think about my 60-degree angle in my unit circle. And sine of any 60-degree angle is guaranteed to be root 3 over 2, right? Now there's a question mark here. But I mean, if you think about it, if we were to kind of complete this picture and look at all the angles around the circle whose reference angle is 60 degrees, right? That they are 60 degrees off the x-axis, either up or down. For all of these guys, they would have to go right half and up or down root 3 over 2. Or I guess to get to this point out here, I'd have to go left a half and up root 3 over 2. And here we'd have to get to this point, we'd have to go left a half, down root 3 over 2. To get to this point, I'd have to go right a half and down root 3 over 2. See if I got all my signs right. So this is kind of starting to fill in the unit circle in its entirety, and it's really not necessary. There's a faster way to do it. But I just want to point out that for all of these slices of pi whose reference angle is 60 degrees, they all have a sine value of root 3 over 2. Now, some are positive and some are negative, and that's what we got to figure out here, okay? But there's a faster way to do it than to create the unit circle. No quadrant 1, so we can find our reference angle and quickly identify the ratio. And then remember that all students take calculus. And what this does is this tells us which trig functions are positive in which in each quadrant. So for example, for the case of 120 degrees, that's in quadrant 2, right? We said that was our angle there in quadrant 2. We see that in quadrant 2, S is positive, sine is positive, so we know that our answer should be positive. Let's add on to that. What about cosine of 240 degrees? Let's say we have to find that value. So again, let's think about first where that is. Where is 240 degrees? So we'd have to go, well, there's 180 degrees halfway around the circle. I'd have to go 60 more to get to an angle of 240 degrees. So again, that 60 is important. That right there is the reference angle. It's telling us how we've sliced the pizza. And because I know the reference angle is 60, I know that cosine for any reference angle that's 60 is guaranteed to be a half, right? Going back to this picture where the reference angle is 60, all the cosine values are a half. It's either just positive or negative. So it's definitely a half. Now I got to think of all students take calculus. And we are here in quadrant 3. In quadrant 3, only the tangent would be positive. That means cosine must be negative here. So you could really make quick work with any angle you're given, as long as you can identify where the angle is, its reference angle, and then you need to make sure you know the first quadrant of the unit circle. That combined with all students take calculus will help you figure out the signs. Let's try a tangent example before we're done here. Let's say we wanted to find tangent of 330 degrees. All right. The unit circle doesn't tell us directly our tangent values, right? When you look up here, we're only given our cosine and sine values on the unit circle. But thanks to trig, there's many identities that can help get us there. So if you recall, you should have seen this, but if not, you'll see it soon. We'll take a look at it now. From the point definition of our trig functions, sine of any angle is the y value over the r value, right? We're talking about for any angle theta and any point on that terminal side, there's an X and a Y and an R and a theta all associated with getting to that point. And so sine is defined this way. Cosine was defined this way, X over R. And tangent is y over x, right? That's the point definition of our trig functions. You could use that. Often it's easiest to use SOHCAHTOA, right, when working with a lot of trig problems. So it's whatever the problem, whatever method suits the problem best. But if you just notice right here, if I were to take sine of theta over cosine of theta, that would be the y over r divided by x over r. So if we're going to divide our fractions, we'll just leave the first alone and multiply by the reciprocal. So those r's would cancel and you would get just y over x, which is tangent, right? So it turns out that if ever you take sine of an angle over cosine of an angle, you're simply just finding tangent of that angle. And we could use that here. If I want tangent of 330, then really I could find it by taking sine of 330 over cosine of 330. Oops. So it's a little more work involved than memorizing the tangent values, but I find it hard to memorize all this stuff. So I just stick with quadrant 1 of the unit circle and I find it this way. So let's figure out sine of 330 and cosine of 330. We got to first identify where is 330. So if I went all the way around the circle, we'd be at 360. So we need to give back a little bit. How much did we give back? We gave back 30 degrees. So I'm 30 degrees off the x-axis. That got me to 330 here. So 30 degrees is my reference angle. So when I consult the unit circle, I'm looking at the 30-degree slice now. And I could see that the cosine value would be root 3 over 2, and the sine value would be 1/2. So that's guaranteed, because that's the slice of pie we're working with. For a 30-degree reference angle, sine is 1/2, cosine is a root 3 over 2. Again, now the question is, are they positive or negative? So let's figure that out. All students take calculus. We are in quadrant 4. Cosine should be positive, sine should be negative. So the cosine value is positive. The sine value is negative. So didn't leave myself much room, but let's clean this up. I would have negative 1/2 times the reciprocal of the denominator. The 2's would cancel and I'm get negative 1 over root 3, which you might see the books rationalize and write this way, negative root 3 over 3. Okay, so again, you can find any trig function at any angle if you take advantage of the unit circle, or at least the first quadrant of the unit circle, and remember that little trick that all students take calculus. Hope this helps.